All right, as we continue on here in 5-6 with the last couple examples, we're going to look at rationalizing denominators with roots in them that have more than one term, okay, in the denominator. Okay, now I just talked about in the previous example a conjugate. A conjugate is something like this. If I said, what's the conjugate of 2 plus square root 3? The conjugate of that is 2 minus square root 3. You still have 2 for the first term, square root 3 for the last term. The only thing that's different is the sign in the middle. If I said, what's the conjugate of 4 square root 2 plus 6? Well, that would be 4 square root 2 minus 6. So you need to understand, because we're going to apply this as we rationalize the denominators, you need to understand what a conjugate is. It's pretty simple. The sign in the middle is the only thing that's different. Okay, so if you look at this first example right here, example A here, we have 1 minus square root 3 divided by 5 plus square root 3. I cannot just cancel my square root 3's here, because I have a minus and a plus on the top and top and bottom, and that does not undo division. So you can't just cancel square root 3's. We need to get rid of, remember, for things to be simplified when you're dealing with radicals, you cannot have any roots on the bottom. To get rid of roots on the bottom here, when there's more than one term, you need to multiply by the conjugate of the denominator. So the conjugate would be 5 minus square root 3. Now, if I do that on the bottom, I must also do that on top. Now, because I have a binomial on top, I'm going to also put that in parentheses. So, what happens here, and why this gets rid of what gets rid of the roots in the denominator, we'll show you. Let's FOIL the bottom together. I'm going to do 5 times 5, which is 25. Now, if you do your outside and your inside, I want you to know, and this is why we multiply by the conjugate, I want you to look at what happens. For my outside, I'd get minus 5 square root 3. For the inside, I'd get plus 5 square root 3. Well, they drop out. You get 0 square root 3. So you end up not getting a square root 3 term. So I'm not even going to write down the outside and inside, because together you end up with opposites. They drop out. But then, if we look at multiplying our last terms, I have square root 3 times negative square root 3. Square root 3 multiplied by negative square root 3. Now remember, square root 3 times square root 3 is just 3. Remember, it's the square root of 9. So this is just going to be negative 3. So I'm going to get, when I multiply square root 3 times square root 3, it's 3, but I have a minus because I'm multiplying a positive times a negative. Notice, we're not going to end up with a radical in the denominator, which is why we multiply by the conjugate. Now on top, you will not have things dropping out. You just need to FOIL that together, because we have a binomial times a binomial. So I'm going to do 1 times 5, which is 5 for my first terms. Then I'm going to do my outside terms. That's 1 times negative square root 3, so it's minus 1 square root 3. Then I'm going to do my inside terms. 5 times negative square root 3 is minus 5 square root 3. And then I'm going to do my last terms, which is negative square root 3 times negative square root 3, which will be plus square root 3 times square root 3 is 3. Okay, now I can do some simplifying in this particular one, both on the top and on the bottom. On top, I'm going to put 5 and 3 together. They're both positive, so that's 8. I'm going to put negative 1 square root 3 and negative 5 square root 3, which is minus 6 square root 3. Remember, it stays square root 3 when you combine them. So you just combine your coefficients of negative 1 and negative 5. All over, 25 minus 3 is 22. All right, when you get down to this step, now you have to check to see if you can reduce. Okay, sometimes you can, sometimes you can't. Okay, here's I'll show you a little shortcut. I'll actually talk about the way that you do it. Okay, technically on top, when you see 8 and then look at the coefficient there of 6, there's a common factor of those two numbers. It's 2. So technically what you're doing, okay, is taking out a 2, and I'm left then with 4 minus 3 square root 3. I'm taking a 2 out of those. Okay? And then that's over 22. Now, because this is multiplication right here, you can cancel. 2 goes into 2 once and into 22 11 times. Now, what I tell kids is you don't have to necessarily show the factoring. If you have this, 8 minus 6 square root 3 all over 22, if there is a common factor of those three numbers, you can basically divide or reduce those three numbers by that common factor. See how 2 goes into them? 2 goes in here 4, in here 3, and in here 11. So it's 4 minus 3 square root 3 over 11. So if you don't want to actually show the factoring out, as long as you can reduce from both the coefficient, the 6 and the 8. You know, if this was 8 minus 5 square root 3 on top, you can't reduce the 8 and the 22, just that. It has to be also with the second term. Okay? Now, you won't always be able to reduce. But let's go to the last example right now. Okay? So basically it's very similar to the one we just did. We're going to multiply by the conjugate on the bottom. 4 plus square root 3. So we multiply on top by 4 plus square root 3. Okay, on the bottom. Okay, really all you have to do is your first and your last, because you're choosing the conjugate, so your outside and inside will be opposites and drop out. So 4 times 4 would be 16. Okay, outside and inside are going to drop out, so now you do your last. It's a negative times a positive, so it's minus square root 3 times square root 3 is 3. So on the bottom I'm going to have 16 minus 3. We'll simplify that in a little bit. Let's actually FOIL the top together here. So 2 times 4 for my first term is 8. Outside terms, now you're not going to multiply the 2 and 3 because the 3 is under the root. You're just going to write it as plus 2 square root 3. It's kind of like if you have 2 times x, so you write it as 2x. Inside terms, again, 4 is not under a radical, 3 is, so we just write it as plus 4 square root 3. And then I'm going to do my last terms, square root 3 times square root 3, positives, plus square root 3 times square root 3, just did it here, is equal to 3. It's the square root of 9, but it is equal to 3. Okay, so now let's do some simplifying. On the bottom, I'm going to get 13, 16 minus 3. On top, I have 4 terms. I'm going to combine my constants, or my number terms. 8 plus 3 is 11. I can also combine these two terms. Okay, they're both square root 3 terms, so you add the coefficients or combine the coefficients. They're both positive, so it would be plus 6, and it stays square root 3. When you add or subtract like radical terms, the square root part stays the same. Okay, now, can I reduce on this one? And this one you cannot. There is no common factor of 11, 6, and 13. So this one is already reduced, and that would be your answer.